అసలు ఈ చెప్పిన మాట వింటలేదు ఇది. గుడ్ ఈవినింగ్ మహాగణాధిపతయే. గుడ్ ఈవినింగ్. Only two are joined. Good evening. Yes. Good evening. Ask the remaining students need to join fast. You need to start the class now. Silhasini, good evening. Yeah, Mahaganadhipataye. There is a circle with center O, and there is a card AB. AB is the card of the circle with center O. Now, if I join the endpoints of the card with the center of the circle, we can observe an angle at the center. Means this angle. Angle AOB is called central angle or angle subtended by chord AB at the center. AOB is called, angle AOB is called either central angle or angle subtended by the chord AB at the center. Okay na? Right. Now, this chord AB is dividing the circle into two parts. One is minor arc, the other one is major arc. Okay na? AB is the minor arc. I will consider one more point over here, AP. AP is the minor arc and AQB is the major arc. AQB is the major arc and AP is the minor arc. Okay? Now, if I join QA, QB, if I join QA and QB, I can observe one more angle over here, that is angle AQB. Then what we call that angle AQB? What we call angle AQB? We can call it as angle subtended by chord AB, angle subtended by chord AB at a point on the remaining part of the circle. What we call angle AQB? Angle subtended by chord AB, angle subtended by chord AB at a point on the remaining part of the circle. Okay. If we consider this is one part and this is the second part, okay. So angle AQB is the angle subtended by the chord AB at a point Q on the major arc, you can say. Okay? And if I join PA, PB, if I join PA, PB, and here you can observe one more point over here, one more angle over here. So what we call this angle? Angle subtended by chord AB at P, at a point P on the circle. Children, here you are observing 3 points, means 3 angles over here, 3 angles. One is angle AOB, the other one is angle AQB, and this one is angle APB. Okay, na? Now, what we call angle AOB? Once again, angle AOB is called central angle or angle subtended by chord AB at the center. Angle subtended by the chord AB at the center. Next, what we call AQB? Angle AQB. Angle AQB, what we can call it as? Angle subtended by chord AB at a point Q on the circle. Angle subtended by the chord AB at a point Q on the circle. Okay, na? Now, and what we call angle APB? Angle subtended by chord AB at a point P on the circle. Okay, na? Now, we can call these angles. There is another name for these two angles, that is inscribed angle. Inscribed angle. This is also same. So this one is called central angle, and this one is called, these two are called as inscribed angles. Inscribed angles. Okay, na? Now, yeah, see this. Here, chord AB, it is subtending 2 angles. It is subtending 2 angles. One is one angle at the center and the other angle, one angle at the center and the other angle on the remaining part of the circle. Remaining part are at a point Q on the circle. Okay na? See, if you observe here, both the angles, angle AOB and angle AQB, if you observe them, they are in the same segment. They are in the major segment. Okay? Both the angles are in the same segment. That is in the major segment. Okay na? Yes? AB is a chord. This is what we call minor segment and this is what we call major segment. Okay? Now if you observe angle AOB and angle AQB, both the angles are in the same segment. Okay? But one angle is at the center and the other angle is at a point on the circle. But both are subtended by same chord. Okay? Now, if it happens so, if the condition is like this, then there is a property that angle AOB is equal to 2 angle AQB. Angle AOB is equal to 2 angle AQB. Okay, na children? Means central angle is equal to double the inscribed angle, or AOB is called central angle, AQB is called inscribed angle. Okay? So central angle is equal to double the inscribed angle. This is a very, very important property which we use for solving problems in the 9.3 exercise. Is that okay, children? Is that okay? Is that understood? Okay. Now, one more property I am going to tell you is, see, circle with center O, chord AB. Circle with center O, chord AB. Now, I am considering 4 points on the circle. Moreover, they are on the major arc. All the 4 points are on the major arc. What I will do is, I join the endpoints of the chord. P means I join the points, point P with the endpoints of the chord AB. In the same way, QA, QB, RA, RB, SA, SB. Okay, na? I took only 4 points. You can take many points also. Okay, on the major arc. Right. Now, here we can observe 4 angles. Angle APB, angle AQB, angle ARB, angle ASB. All these angles are subtended by same chord AB. All these angles are subtended by same chord AB. Okay na? Moreover, at different points P, Q, R, S on the circle. So what the property says, since all these angles are subtended by the same chord, they are equal. All those angles are equal. Okay na? Angle APB, angle AQB, angle ARB, angle ASB, all those angles are equal. Why? Because they are subtended by the same chord. They are subtended by the same chord AB at different points on the remaining part of the circle or in the major arc end. Okay na? Angles subtended by the same chord. All those angles, all the four angles are subtended by the same chord. Okay na? Yeah. Now, sir, if we take three points on the minor arc, a student asked me a question like this, sir, if I take 3 points on the minor arc, you have taken 4 points on the major arc, and you are saying that all these 4 angles are equal. Now, what I want to ask you is, if I take 3 points on the minor arc, not only 3, like this, I took 3 points on the minor arc, and I am joining all these 3 points with the endpoints of the chord. Now I got 3 angles. So according to you, these 4 angles are subtended by the same chord. In the same way, these 3 angles are also subtended by the same chord AB, but in the minor segment, and these are in major segment. Can I say angle ACB equal to angle ADB equal to angle AEB? Is this true? That was the question by that student. What do you say, children? Are they equal? Yes, they are equal. They are equal because these 3 angles also subtended by the same chord AB, subtended by the same chord AB in the minor segment. So they are equal. And these 4 angles subtended by the same chord AB in the major segment. That's why these 4 angles are equal and these 3 angles also equal. Okay na? Is that understood, children? This is the same property. So what we call, this is the second property. What we call this property? Angles in the same segment are equal. Angles in the same segments are equal. Here, these 4 angles are in the major segment and these 3 angles are in the minor segment. So, major segment angles are equal and minor segment angles are equal because they are all subtended by the same chord AB. Okay na? Now, one question for you. Yeah. There is a circle with center O. There is a chord AB. There is another chord CD. and there is a point P on the circle. I am joining AP and PB, APC and PD. Can I say angle APB and angle CPD are equal? Are they equal? Angle APB and angle CPD, are they equal? Hey children? No. Very good. No, they are not equal. Why? Can anyone say the reason? Why? What is the reason? What is the reason, children? Anyone? I want reason from your side. Why they are not equal? Why angle APB is not equal to angle CPD? Because they are not subtended by the same chord. Very good. They are subtended by different chords. APB is the angle subtended by angle chord AB, and CPD is the angle subtended by chord CD. Okay, na? But at the same point, even though they are making angles at the same point P, but they are of different chords. So that's why they are not equal. Okay, na? This is the second property. Now, third property. Third property. Center. Now I am considering diameter. AOB is the diameter. Children, you know. Diameter is the longest chord in the circle. Diameter is the longest chord in the circle. Okay? Now, this is my central angle. I am taking one point P. I am taking one point P on the semicircle AB. I am taking one point P on the semicircle AB. Why I am calling APB as semicircle? Can anyone say? No. My question is, can I say APB is a semicircle? APB, can I call it as a semicircle, children? Can I call it as a semicircle? Why? Reason? Reason, children? Because diameter divides the circle into two equal parts, and each equal part is called a semicircle. Yeah. Now, what I will do is, I will join PA, PB. I will join PA and PB. Now I got one angle over there, angle APB. I got one angle over there, angle APB. Okay. Can I say APB is angle in the semicircle? Can I say like that? If the chord AB becomes diameter, then I am taking one point. Then I am taking one point P on the semicircle. So PA, PB are joined. I got a point, I got an angle APB. Can I say it as angle in a semicircle? Angle in the semicircle. Yes. Because this angle is in the This angle is subtended by chord AB at a point P on the semicircle. So we can call it as angle in the semicircle. So children, can anyone say what is the measure of this angle? Measure of this angle. See, AOB is diameter. So angle AOB is 180 degrees. This one straight angle. Okay na? Now, according to the first property, central angle is double the inscribed angle. According to first property, central angle is double the inscribed angle. So 180 degrees is equal to 2 into ABB. Then what is the measure of ABB, children? What is the measure of ABB? AOB is a diameter, so central angle at the center is 180 degrees straight angle. We are observing straight angle over here. So its measurement is 180 degrees. Okay. So central angle is 180. But we have a property that central angle is double the inscribed angle. AOB is equal to 2 into ABB. The angle ABB is 90 degrees. Very good. Angle ABB is 90 degrees. Good. So, what is the other name of 90 degrees? Can anyone say? What is the other name? What we call 90 degrees with another name? Anyone? Right angle. Very good, Sanat. Right angle. Good. So, the third property is angle in the semicircle is a right angle. Angle in the semicircle is a right angle. This is the third property. What is the first property? Central angle is double the inscribed angle. Second property, angles in the same segment are equal, either minor segment or major segment, or angles subtended by the same chord at different points on the circle are equal. That is the second property. Third property, angles in the same semicircle. Angle in the semicircle is a right angle. Third property. Okay, na? These are the three very important properties that you should know for solving the problems in the 9.3 exercise, children. Okay, na? Okay, so that's all for today. We'll continue the lesson tomorrow in the class. Okay, na? There is one more property called cyclic quadrilateral property. We'll see it tomorrow, then we'll solve the problems tomorrow in the class. Okay, na? Okay. Dhanyavad. Mahaganadhipataye namaha. You can leave the class. Thank you very much. If you like this class, click on the like button. Yeah, you have to prepare RS Agrawal. Thank you very much. Thank you. Bye.